I have a
Did
question
not you
about
say that?
tangents. I remember in geometry we had a line
That's a
that
line
He actually said
that
this is
just touches, and secant is a line that goes clear through the circle, yeah.
So, does that have anything to do with this?
Because he corrects him.
I never thought about it, that's a great question, why don't you Google it sometime, not now.
Okay, sure.
Okay, all right, so here we go, guys, we're ready for number 4. Ready for some excitement now, because we're going to look at what are called the quadrantal angles. The quadrantal angles. What we mean by quadrantal angles are angles that terminate on an axis. So, an example would be 0 degrees, 90 degrees, negative 180 degrees. These are called quadrantal angles. They terminate on an axis. We can't draw triangles for quadrantal angles. For example, sine negative 270. Negative 270, now remember, negative 270 would be right here. Would you agree with me? If you're going to draw a triangle, it has to be constructed with a perpendicular to the x-axis. So there's always kids that say, well, I can draw a triangle. No, you can't. The perpendicular has to be dropped to the x-axis. You don't just randomly draw in some diagonal line. So what we do is, this is negative 270. What we do is, we imagine a circle that contains that point right there, that angle right there. Now here's the good news. You can make that circle whatever size you want it to be. Now as long as I'm making the circles, they're going to have a radius of 1 because 1 is the easiest number. But you'll see in a second, if you want your radius to be 5 or root 17, it doesn't matter. But I'm going to let my radius be 1. So the radius of my circle is 1. It can be anything, you'll see. If the radius of that circle is 1, what are the coordinates of this point right here?
0, 1.
0, 1, right? In other words, x is 0, y is 1, and r is 1. So if I want the sine, what's my definition for the sine? Don't say opposite over hypotenuse. What's the other one? Y over r. So y over r is 1. The sine of negative 270 degrees is 1. Now, remember when I said you could use whatever radius you wanted? Let's suppose you wanted to use 11 as your radius. Okay, well, what would that change? Well, now this point would be 0, 11. But when you build your ratio, see how it's still going to be 1? So generally speaking, we use what's called the unit circle. In other words, we let the radius be 1, and then all these points are just 1s and 0s and negative 1s and 0s. Okay, pretty easy. Tangent 3 pi. Let's try to do this without changing it into degrees, although you may always change into degrees if that is what works for you better. But let's try to do it without. Start here. Positive, so it's going up, right? 3 pi. Now wait a minute. What did we say about all the way around? 2 pi. So we have to go all the way around and then another half. So we're over here now. Would everybody agree with that? Well, again, you're on an axis. You can't make a triangle. So envision a circle going through that point. Let the radius of the circle be 1. So what will be the coordinates of this point over here then?
Negative 1, 0.
Negative 1, 0. we want tangent. Okay, stop and think. Tangent is opposite over adjacent, but in terms of our circular definitions, it would be y over x. So y over x would be 0 over -1, which is 0. So the tangent of 3 pi is 0. Secant, 11 pi over 2. Now wait a minute. Is that a normal angle? Is that a big angle? Is that a little angle? What is 11 pi over 2?
It's huge.
That's pretty big. In mixed number form, wouldn't that be like 5.5 pi's? Well, remember, what's a revolution?
2 pi.
2 pi? And another revolution would be
4 pi.
4 pi. So basically, this thing is gonna spin twice and have 1.5 pi's left over. Would you agree with that? I'm trying to figure out where to draw this angle.
3/4.
So since that's so big, I don't wanna just keep spinning, so I'm getting rid of all this extra stuff. So in radians, I get rid of 2 pi's. Oh wait, what am I doing? Finding a coterminal angle, subtracting revolutions. So I get rid of a couple revolutions. Where is 3 pi over 2? Now that's 1.5 pi's.
Is that 2?
Where is that? All the way around is 2 pi. Halfway is 1 pi. So right here? Would you agree with that? Every quadrant is half a pi. So we're down here. Okay, so I'm doing my circle. What are my points down here? If my radius is 1, what's my x and y down here? 0, -1. So x is 0, y is -1, and r is 1. Okay. Now I need secant. Secant's reciprocal of cosine. Cosine is x over r. So this will be r over x, which is, undefined. There is no secant for 11 pi over 2. It's undefined. Tess?
So I'm confused where you're starting. You start the x.
You start here always.
And go upward.
Depends if the angle's positive or negative. If it's positive, we go up. If it's negative, we go down.
For the little graph here, could you start with a 90 at the top and -180 on the side? Did you just put -180 because if you go down, it would be -180?
Yes, yes. It would also be positive 180.
Yeah.
Yep, yep. I just wanted to show you that there are lots of quadratic angles, and they can be positive or negative. All right, one more of these guys. Cotangent -4 pi over 3. -4 pi over 3 is not quadrantal. Mrs. Ford, how do you know that? Well, what did we say pi was in degrees? What's pi? 180. So a third of that would be 60, and 4 of those would be
240.
240. So this is the cotangent of -240 degrees, which is not on an axis. The axes, the quadrantal angles, are either whole pies or half pies. They're not third pies. Well, where's -240? Negative, go this way, -240, tell me when to stop. Here's -240. I can make a triangle, so I'll make it. this is called my quadrantal angle, or my reference angle. This is my reference angle right here. How big is it? This guy right here, I need to know how big he is.
60 degrees.
60 degrees, Lewis, how did you get that, in case somebody wasn't sure?
Because you just take, because you know that like it's 180 on the quadrantal, so you just add 60 to get 240.
Exactly. We went 60 degrees past 180. Well, then this is root 3, this is 1, this is 2. But ding, 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 we're not in quadrant 1, so something's gotta be negative. What's negative in there? Negative 1, x. All right, we want the cotangent. What's our cotangent?
Reciprocal of sine.
Cotangent will be reciprocal of tangent, so that will be A over adjacent over opposite, or x over y, depending on which definition you're using. So negative 1 over root 3. And I checked with Mr. Shadio. He says, and he's the expert in all things AP, he says we need to rationalize if they're root 2s or root 3s. So in other words, all of our special triangles, we're gonna rationalize. But when we start doing other problems and we get root 5s and root other things, we won't have to rationalize. But all of these should be rationalized. You okay with that? Here's one that we won't rationalize, this very next problem. All right, let's see what's happening here. Given that the sine is 3/7 and the tangent is negative, find all the rest of them. So find cosine, secant, cotangent, cosecant, and tangent. All right, which one of these do I know right away? Cosecant? I know it has to be 7/3. Would you agree with that? Now, this, you have to think about this. It's very, very easy, but it's like a puzzle. There are 4 different triangles that we could draw to describe any given situation. If we have one of the functions given. In this particular case, the sine has to be positive 3/7. We know that the hypotenuse or the radius will never be negative. Hypotenuse, radius, never negative. X and Y can be negative, radius cannot. So if we want the sine to be positive, then doesn't that mean that 3 has to be positive? Because this is going to be positive automatically. Well, where is Y positive?
First quadrant.
Above, top half, right? So we're talking about one of these 2 pictures. Would you agree with me? But in addition to the sine being positive, the tangent has to be negative. So it has to be quadrant 2. Because quadrant 1, everything's positive. So it's gotta be quadrant 2. So this is the picture that I'm gonna use for this problem. Now, what is my next step?
You can solve for x.
I gotta find x, find this, and to do that, I'll use the Pythagorean theorem. So what's that gonna be? The square root of 40? 2 root 10? Be careful. It's in quadrant 2.
Negative
So
2.
it's negative. So now we can fill in everything else. What's the tangent?
3 over
3
rational.
over negative 2 root 10, no need to rationalize, he says, we're gonna leave it like that. The cotangent then is negative 2 root 10 over 3. What's the cosine?
Negative 2 root 10 over 7.
Negative 2 root 10 over 7, making the secant 7 over negative 2 root 10. The sine SIGN, the SIGN of your functions depends totally on which quadrant you are in. So you've got to pay attention to the quadrant you're in so that you get the right positives and negatives. That is awesome.
Yeah. Sorry, I missed that part. How did you figure out that it was in that quadrant out of the bow tie butterfly?
Okay, what did you think about? This is what we were given right here. So what do you think about when you look at that?
Oh, you.
So think of your definitions. What sign?
So sine is opposite over hypotenuse.
Or y over r. So if y over r has to be positive, it's positive 3/7. And this is always positive, r is always positive, then y has to be positive.
Yeah, so it has to be on the
That
top.
happens here or here,
Yeah.
okay? But the tangent has to be negative,
Oh, it has to be less than 0. Okay.
and nothing's negative in quadrant 1, so it has to be a quadrant 2, right? Okay. So now we're gonna look at 6A, which is a big, bad guy here, and let's see if you can figure out how in the world we are going to figure out this without a calculator. Leah, what were you doing on your calculator?
I was multiplying the top by 180 and then everything divided by 2.
Okay, so
and
you
then
were
divided by
changing,
36.
okay, so she is changing this into degrees, basically, is what you're saying, right? So she said, I know pi is 180. So I'm gonna take that times 180 and divide it by 2 on my calculator. That would be easy. And that would give you the degree measure of this angle, right? You could do that. It's totally not necessary though. What were you gonna do after you got the degree measure?
Divide by 360.
Oh, and why would you divide by 360?
See how many revolutions I would have to
Exactly.
do.
So why don't we leave it like it is? And you were gonna take out 360s. What do I need to take out of this? If I leave it in radians, what's a revolution? 2 pi, right? So what if I change this into a mixed number? I can do that without a calculator. That's easy arithmetic, right? I'm gonna change this to a mixed number. And I say it's easy arithmetic. Keep an eye on me, please. Did I do that right? So what does that mean? That means 28,900 whole pies and then a half a pie? Tell me about this. What does that look like?
That's just a bunch of.
That's just a bunch of revolutions. Remember, every revolution is 2 pies. So isn't this like 14,450 revolutions? This part right here? Every revolution is 2 pi, not pi, 2 pi. So I have this many pies, which is this many revolutions. What does that do when I draw it?
Cancels.
Just spins around, right, a whole bunch of times. The only part of this problem I really care about is that. What's pi over 2?
Oh,
So this angle, after all that spinning around, is right up here.
Could you just take out the 557,800, like at the very beginning?
No, because those are halves. You have to take out 2 pies. You're allowed to take out 2 pies, quantities of 2 pies. You can't take out halves, because halves might give you another place on there. Just like what she said, she was gonna take out 360s. You wouldn't take out 90s, you wouldn't take out 180s, you take out 360s. All right, so here we go. We're up there at the top. That's the 0.01. What do I want? The sign. I let my radius be 1. So what's the sign of this guy right here? No. Sine is y over r.
1.
It's just 1. Yeah, it's just 1. Take your calculators out. We're gonna do a couple of different things. Put it in radians. Put your calculator in radians. And type this one right here. Type that in. Make sure you're in radians. Type sine 57,801 pi divided by 2. Tell me you got 1. Right? Now, just for fun, let's do what Leah was doing. Go ahead and change this into degrees and do 57,801 times 180 divided by 2. That's a big angle, isn't it? How many degrees is that?
The same number, but then you get 0.25, so that'd be a fourth of 360, which
Yep.
is 9.
Exactly. Your trigonometric functions are circular functions. So we can just keep going around and around the circle and generating exactly the same points. Does that make sense to you? It's that coterminal idea. Whatever happens here is gonna happen the exact same thing's gonna happen if we go around an extra time, and an extra time, and an extra time. So that's what allows us to take a big angle and shrink it down to the bare minimum, and then deal with that instead of this big ugly thing. One more, quickly. Secant negative 2295, no calculator. We'll do the calculator in a second to check. But secant negative 2295. Now this one's in degrees. So what do we want to weed out? Extra 360. So we're going to take 2295 and divide it by 360. So 760. I got it to go in 6 times and leave me with 135. Did I do that right? Now do be careful. Remember, the original angle was negative, so this is actually negative 135 left over. I'm taking out negative 6 revolutions, and I've got negative 135 left. So where's negative 135? Negative 135, about right there. Perpendicular to the x-axis. How big is my reference angle? 45. So the sides are 1, 1, root 2. Bing, 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 bing. You're not in quadrant 1, so mark your negatives. Both the ones are negative. Cosine, which is x over r, but we're doing secant, so it's r over x, which will be root 2 over negative 1 or negative root 2. Oh my gosh, don't you feel powerful and smart? Good job, good job. that the last problem?